Hello everyone. This tutorial will discuss Honeycomb Perforated Pattern, and will be divided into 3 sections. The first section will be the introduction of the Honeycomb Pattern. Then, in the second section, we will discuss about how to use and create the Honeycomb Pattern in tooling mode. In the last section, we will discuss the use of Honeycomb Pattern in laser mode. We also make a summary of Honeycomb Pattern before ending this tutorial. The Honeycomb Pattern is a new feature introduced in Image2Punch Pro, version 8. Most pattern types in Image2Punch only have one tool shape, located at a node of perforated pattern grid. As we can see, this is a grid of stippling pattern, and the nodes are in red, located at all the intersection of the grid. This is where a particular tool, such as hexagon shape, will be put on it. Depending on the calculation, each node may be filled with particular tool shape that connected with image intensity. And you can see that the size of the hexagon is varying depending on the color intensity at a particular node. For all other existing pattern, from rectangular pattern, angle pattern, random, or stippling, each node in the grid can only be used for a single tool. However, for Honeycomb Pattern, each node may contain one tool, or more tools that are located around the node. And this is an example of 3-segment pattern subtype. As we can see, the red circle represents its node. And there are 3 tools, inside the black circle, have different angle and position. They are represent a cluster pattern in the 3-segment pattern subtype. And this is the pattern result, created by using the 3-segment pattern subtype of the Honeycomb Pattern. And this is an example of 6-segment pattern subtype. We can also see that there are 6 single tools around the node. And this is the perforated pattern based on the 6-segment pattern subtype. In Honeycomb Pattern, there are 5 pattern subtypes, and they are categorized by the number of the tool that gather around the node. Let's talk in general about them. The first one is a 1-segment pattern subtype. This subtype is only use a single tool for a node and behave similar like normal perforated pattern. The ideal shape is a hexagon shape. The second one is a 2 segments pattern subtype. The ideal tool shape is a trapezium shape. The third one is a 3 segments pattern subtype. The ideal tool shape is like a diamond shape. The fourth one is a 2-dimensional box-like pattern. Although did not really resemblance as a honeycomb shape, this subtype is still give a good pattern variation. The ideal shape of this is a triangular shape. The last one is the honeycomb pattern subtype, or a 6 segments pattern subtype. The ideal shape is a triangular shape that have 3 equilateral sides. Now, let's talk about ideal shape. It has been mentioned many times about the ideal shape, especially when we talk about the pattern subtype. So, the ideal shape is the shape for particular honeycomb pattern subtype that have to meet certain parameter criterias. From here, we can see what kind of shape that is required for each honeycomb pattern subtype, as well as their origin point location, marked by a blue dot. The ideal shapes have to meet the dimension constraints including the origin point of 0, 0, where the location may not be the same from one subtype to another. Let's go deeper to know the ideal shape for each subtype. For the 1 segment, it has to be hexagon shape with equal sides and equal corner angle as we can see from the illustration. For the 2 segment, the ideal shape will be like the shape of trapezium, and its origin points are the half of its width and height. For the 3 segment, the ideal shape is like a diamond shape with 4 similar sides length. Then the corner angle must meet 60 degree and 120 degree. The origin point will be the half of its width and height. For the 4 segment, the ideal shape is an upside down triangle with 1 90 degree corner angle and 2 45 degree corner angles. The position of its origin point will be calculated like the illustration. The vertical position of its origin point is a third of its height. Then for the 6th segment, the ideal shape is triangular shape with equilateral sides. All corners have to be in 60-degree angle. The vertical position of its origin point is a third of its height. Now, how about if we want to use shape other than ideal shapes? Yes, we can definitely use the non-ideal shape, but the shape have to meet some criterias. First, the shape have to inherit its ideal shape anatomy. The ideal shape of one segment subtype is hexagonal. As we can see here that this hexagon shape have radius corners, because of that, this shape is no longer an ideal shape. However, that shape is still resemblance the ideal shape. Now, let's see other example for non-ideal shape for hexagonal. From here, we can see clearly that the two shapes in red are still inherited the shape of its ideal shape in blue. Second criteria is that the shape have to be within its ideal shape. From here we can see that the blue shape is the ideal shape, and the shape in red is the non-ideal shape. The non-ideal shape cannot have an area that outside the area of ideal shape. If the non-ideal shapes, which is in red lines, have a portion of the shape that out of its ideal shape in the blue line, then the desired minimum gap will be incorrect. The third criteria is that the non-ideal shape original point have to be in the same exact location as the ideal shape. From here, we can see that the origin point of the non-ideal shape is in exact location similar to the ideal shape, although the shape is not symmetrical. And when this non-ideal form the honeycomb cluster, the formation will be good as this illustration. If all these three criterias are met, the use of non-ideal shapes can give a unique and eye-catching perforated pattern design. Now, we have a little bit understanding about honeycomb pattern. In order to use and apply the honeycomb pattern, we need to create and import the tool shape from a DXF file. If we want to use an ideal shape for the one-segment pattern, we can simply create the hexagon tool by using the predefined hexagonal tool library. However, if we want to use a non-ideal shape or other pattern subtype, we need to create the shape using CAD software, then save them in a DXF file and import them into Image2Punch via the Custom Tool Library dialog box. The procedure to import the tool shape from a DXF file into Image2Punch follows the standard process similar to importing the custom tool shape that are not predefined in Image2Punch. Information about importing custom tool can be found from Image2Punch website as you can see from here. To generate the honeycomb pattern, we can use either punch mode tooling and laser mode tooling like other pattern type in Image2Punch. In this second section of honeycomb tutorial, we will create the honeycomb pattern in punch mode. First of all, the very first step in generating honeycomb perforated pattern is to decide what kind of pattern subtype that we are going to use. There are 5 pattern subtype in honeycomb pattern. For this tutorial, we are going to use the 6-segment pattern subtype. And the ideal tool shape for this pattern subtype is an equilateral triangle. The shape will be an upside-down triangle, where the origin point is located at the third height when measured from the top. In punch mode, we need to create all the tools that we will use for the perforated pattern. The tool shapes can be a mix of non-ideal and ideal tool shape. For this tutorial, we are going to use 7 tools. As we can see, they are a mixed set of ideal and non-ideal tool shape. The smallest tool is 4 mm equilateral side length, and the largest one is 15 mm long. As we can see, the tool number 1, 4, 5, and 6 are non-ideal tool shape. And for tool number 2, 3, and 7 is the ideal tool shape. After all tools have been created in CAD software and saved in DXF for each tool, the next step is to import all the tools into Image2Punch. Now, open Image2Punch by clicking the icon. Let's open the dialog box, and let's import the tool one by one. We name for each tool as Honeycomb 1 for the smallest one, and Honeycomb 7 for the largest tool. In Honeycomb Pattern, the largest tool is important to determine the grid calculation. From the largest tool, we can find the inscribed diameter. This is the diameter that enclosed the whole tool shape. Knowing the inscribed diameter of the largest tool, as well as the desired minimum gap for the pattern, Image2Punch can then calculate the grid for Honeycomb Pattern. In here we can see that the red triangle is when the largest tool has been offsetted by a half of its minimum gap. Then a new inscribed diameter in red can now be used to determine and calculate the honeycomb grid. Then, this grid formation will be used to form the honeycomb pattern for the 6-segment subtype. Now, let's open the honeycomb pattern dialog box. If the largest tool is an ideal tool shape, the calculation of its inscribed diameter can be done automatically by clicking or ticking the auto-inscribed diameter box. However, if the largest tool is not an ideal shape such as the shape that is in pink, we need to untick that box, then specify the parameter to calculate the inscribed diameter of the ideal shape of that non-ideal largest tool. The important reason why we always need to use and calculate the inscribed diameter from the ideal shape is because the diameter from the ideal shape will always be larger than the inscribed diameter from its non-ideal shape that derived from them. Now, let's go back to Image2Punch. Let's select all the 7 tools to generate the honeycomb pattern starting from small to the largest one. Then, open the honeycomb dialog, and select the last option for 6-segment pattern. As we know that the largest tool is an ideal tool shape, let's click the box for auto-inscribed diameter. By clicking this, Image2Punch will calculate the inscribed diameter, based on the geometry of the largest tool shape, which is an ideal shape. For other parameters, let's use the current setting. Let's specify 5 mm for the desired minimum gap. This is the minimum gap that we want for the pattern. Let's hit the Generate button. And now we can see the result of honeycomb pattern using the 6-segment pattern subtype. Let's then save the pattern in DXF file. Then open it in a CAD file, then we measure the minimum gap. And from here, we can see that the minimum gap is 5 mm, and this is the gap that we want for the perforated pattern. Now, let's open the tool selected list. Then we delete the largest tool, and now the total selected tool will be 6 tools. And the largest tool is now the non-ideal tool shape. Let's find out the ideal shape of the 6th tool. From here we can see that the diameter of the ideal shape is 17.32 mm. And this is the dimension that we will use to calculate the inscribed diameter. Let's open the honeycomb pattern dialog box again. Then we untick the box for auto-inscribed diameter. Then, we simply type 17.32 as this is the diameter of the ideal shape of the 6th tool. Then close the box, and leave all the current setting as is. Then click the Generate button, then we save the pattern into a DXF file. We name it as non-ideal result. Now, what would be the result? If we tick the auto-inscribed diameter while we know that the largest tool is non-ideal, let's do it. Open the dialog box for honeycomb pattern again. Then tick the auto-inscribed diameter. Then close the box. And click Generate button. Then we save the result in DXF and name it as non-ideal auto. Let's open the non-ideal DXF in CAD software. From here we can see that the minimum gap is satisfied, which is 5 mm. This because we have specified the diameter of its ideal shape. Let's now open the non-ideal auto. From here we can see that the minimum gap for the perforated pattern is not satisfied and the minimum gap is less than the desired value. The reason of this is simply that we let Image2Punch calculate the minimum gap based of the geometry shape of the non-ideal, which is actually only 15.32 mm. The result of this that the diameter will be smaller and give incorrect minimum gap of the perforated pattern result. Therefore, the auto calculation for the largest tool that is non-ideal tool shape is not recommended. User must always use the ideal parameters to calculate the inscribed diameter for the honeycomb pattern, especially when using a non-ideal shape. The second way to generate the honeycomb pattern is to select the laser mode tooling. Unlike the punching mode tooling that required you to create and import each tool, we only need to create and import the largest tool shape. The tool for laser mode can be an ideal or non-ideal tool shape. The limitation of this mode is that we can only use a single tool shape, and cannot be mixed with other. However, the advantage is flexibility, as we can generate up to 250 tools with different size, based on a single tool shape. In doing so, we only need to specify the total number of tools to be used, the largest tool parameter, and the smallest tool parameter. They can be either height, width, or diameter. Similar to the punch mode tool, we also need to decide which pattern subtype that we are going to use to generate the honeycomb pattern. After that, we can then create the shape for the pattern subtype. From the tool shape we created, we need to identify 3 dimensions that may be required when using the tool laser mode. They are the width, the height, and the maximum circle that enclosed the tool shape from the origin point. By using one of these 3 dimensions, we can generate a range of tools based on the minimum and maximum value. As we can see, this is the shape that we are going to use for 6-segment pattern subtype. From here, we can see that the width is 15.00 mm, the height is 12.99 mm and the maximum diameter is 17.32 mm. This shape is already imported in Image2Punch and is named as Honeycomb 7. Now, let's open the laser tool dialog box. Then we click the Custom Tool button to select the Honeycomb 7. We can see that there are 3 options based on width, height, or diameter where we can generate a variation of tool for our perforated pattern. For this tutorial, we click the 3rd option by using diameter based. Then type 17.32 for the largest diameter, which is also the true size of the tool that we have selected. And for the smallest diameter, we type 5. The total tool that we are going to use is 30, and we keep the angle rotation as 0 degree. Then, we close the dialog box, and open the honeycomb pattern dialog box. Click the last option in the pattern subtype as this is for the 6-segment pattern subtype. As we know that the honeycomb 7 is an ideal tool shape, we can then simply click or tick the auto-inscribed diameter and let Image2Punch automatically calculate the inscribed diameter based on the geometry of the tool. For other parameter, we keep them as is. Then close the dialog box. Then, we specify 5 mm for the minimum gap, and let other parameter in the current setting. Then, press the Generate button to generate the pattern. As we use more tool variation in laser mode, we can see that the result is better and smooth compared to the one that we generate using punch mode with only 7 tools. Now let we save the result in a DXF file and name it as laser mode ideal. Let's open again the selected tool dialog box, then we select the Honeycomb 6 as the custom tool. This tool is a non-ideal tool shape. As we can see, this tool true diameter is 15.32 mm. Its width is 13.54 mm and its height is 11.99 mm. Now, we select the diameter as the parameter to generate the tool. Then we type its true diameter, which is 15.32 mm for the largest diameter. For other parameter, we simply keep as is. Now, let's open the honeycomb pattern. As we know that we use the non-ideal tool shape, we need to untick the auto-inscribed diameter, and instead we need to specify manually its non-ideal diameter. Instead of type 15.32 mm, we need to type 17.32 mm, which is the diameter of the ideal shape of honeycomb 6 tool shape. Then, we close the dialog box and click the Generate Pattern. Then we save the result as Laser Mode Non-Ideal. From here, we have two DXF files. The first one when we use the ideal shape and let the inscribed diameter is calculated automatically. And another one is when we use non-ideal tool shape and we specify the inscribed diameter manually. Let's open the Laser Mode Ideal and check the minimum gap. From here we can see that the minimum gap is satisfied. Then open the Laser Mode Non-Ideal. From here we can also see that the minimum gap is satisfied even though the largest tool is the non-ideal shape. However, if we use the non-ideal tool, then let Image2Punch calculate automatically the inscribed diameter. The perforated pattern result will have incorrect minimum gap, as we can see here where the minimum gap less than 5 mm. We can also summarize into several points about honeycomb pattern. 1. Honeycomb pattern is a cluster perforated pattern that consists of one or more tools for each node in the pattern grid. 2. There are 5 pattern subtypes in honeycomb pattern family. 3. Each pattern subtype has different ideal tool shape, and has its own specific origin point. 4. Non-ideal tool shape can also be used as long as it is derived from the ideal tool shape. 5. Non-ideal tool shape has to be inside the area of its ideal shape to prevent incorrect grid calculation to satisfy the minimum gap requirement. 6. If the largest tool shape is an ideal shape, we can use the auto-inscribed diameter. 7. If the largest tool shape is a non-ideal tool shape, we need to know its ideal shape dimensions as well as its true non-ideal shape dimensions. These parameters include the maximum diameter, the maximum width as well as the maximum height. The dimension of its ideal shape will be used to calculate the grid of honeycomb pattern, and the true dimension of the non-ideal will be used to generate the variation of the tool if the laser mode tooling is selected. 8. In importing the tool for honeycomb pattern, we need to ensure that the origin point is in specific location for each pattern subtype. I am hoping this tutorial will be useful for you to understand about honeycomb pattern and how to use it for your own project. Thank you for watching this tutorial.